This is worksheet E. We're doing Venn diagrams for probability. We have 2 pages, one with uh, 2 pages, one they each have a context that we're going to get into. So this one is about apartment buildings. How many of them are vacant? Um, Here, 3 vacant ones. 45 have a landline, 82 have people with a cell phone, 40 have people with both. Okay. So the vacant ones are just on the outside looking in. They're they don't have cell phones, obviously. No one's there, and they don't have a landline. So you fill in the chart like this. It's given to you this time. So the 40 comes from um, 82 minus 40, or it could even be 45 minus. Sorry, I'm brain fart. 40 have both, so you just go ahead and put a 40 in the middle. Where does the 42 come from? 82 minus 40. Where does the 5 come from? Um, 45 minus 40. Okay. All right, probability. Where for all of these, we are picking just one apartment building. Can you pick an apartment building that has both? When you see the word and, that's both, which is simply the overlap. 40 out of what? How many apartments are there total? Add these up. We have 90 apartments. One thing you do not want to add, do not add these because you are double counting some things if you do that. Okay? So 40 out of 90, that's an easy one just to make it 4/9. Or if you know your percentages, that's about 44%. So part B, the only difference is it's the word or. So or means one of the characteristics or both. So a landline or a cell phone would be these 5 that I'm highlighting right here. And you could just add those up, and that's 87. The where kids get into trouble is they go, oh, well, 45 have a landline and 82 have a cell phone, and that's 127. But that's more than the total to begin with. Remember the formula for or is A plus B minus the intersection, minus the 40. So 45 plus 82 minus 40 is 87. Or just to show you, if you add up this, and this, 5 plus 40 plus 42. Oop, I had to push the wrong number. 40 and 42, it's 87. So 2 ways to approach this. 87 of the apartments have a landline or a cell phone or both, which is pretty much everything in the circles. It's only these 3 that don't. Um, Letter C. They have a landline, but not a cell phone. Well, that's just these 5. Those are the only 5, 5 out of 90, and you could reduce that. They have a cell phone, but no landline. That would just be over here. These 42 have a cell, but no landline, because these 40 have a landline. So it's just 42 out of 90. Okay. Then E. An apartment has neither one. Where are the apartments that have neither? Those are the 3 on the outside. 3 out of 90, or 1 out of 30. F. An apartment has a landline or a cell phone, but not both. So really, that's saying they have this or they have this, but they cannot have both. So that's 47 of them. 47. Okay. Now we get into some fun. The bar, remember, is a condition. So we're trying to pick an apartment that has a cell phone, but the condition must be satisfied. The apartment we're picking can only come from the apartments that have a landline. So I like to do this. Like, I have to pick from this orange circle, and there are 45 apartments in that orange circle. I like to say that the condition limits the denominator, or it limits the sample size. The sample size for all the apartments is 90, but now we are limited to the apartments that have this condition. They have a landline. So there are only 45 of those. Within my orange circle, how many of them have a cell phone? Well, that would be the ones in the middle. That would be 40. 40 out of 45 would be 8 out of 9. If you, again, just every once in a while, I like to do this. So you might see like 0.88 repeating, like on a quiz or something. H, it has an apartment that has a landline, but now the condition is changing. Now the condition is that it has to have a cell phone. So let me get rid of that orange circle. Now my condition is the other circle. It has to have a cell phone. Within that circle, there are 82 apartments. So that's my new sample size, my new denominator. And of the 82 inside here, how many have what I'm looking for? Have a landline? Well, 40 of them do. So that could reduce if you wanted. Okay. This one, let me go further, do it the other way. Remember the formula. Let me use some abbreviations. Apartment has a landline given a cell phone. Landline given cell phone. The formula says that it is equal to the probability of a landline and a cell phone divided by the probability of the condition. Okay, that's the formula. You always, the L and C on the top, and the condition goes on the bottom. So you're going to get the same answer. I just wanted to show you though. So what's the probability if you pick a random apartment, it has a landline and a cell phone? That would be the and, that would be the middle. So the probability of that is 40 apartments out of 90 over the probability that just a random apartment has a cell phone. A random apartment having a cell phone is this, which is 82 out of 90. If you remember your rules of a fraction divided by a fraction, you keep the first fraction and you multiply by the reciprocal of the bottom fraction. And doing so, the 90s cancel, and look, you're left with what we thought we had earlier, 40 out of 82. Okay? That's using the formulas. That might be a little bit much this time, but all right. Are having a landline and a cell phone disjoint, meaning disjoint means they don't happen at the same time. No. Explain. They can both occur in the same apartment. They can both occur at the same time. J, are having a landline and a cell phone independent. Okay, so independent means the probability of one of them is independent of the other. So the probability, I could word it like this, the probability of a landline, given that they have a cell phone, should equal the probability of a landline, meaning having a cell phone does not impact the probability, has no bearing on the probability. Okay, which means essentially the condition won't matter. Is this true? Okay, so let's find this, which we actually did right here, didn't we? We did that right here, and we got 40 out of 82. Okay, so 40 out of 82. Does that equal the probability of a landline? If you just pick any old random apartment, what's the probability it has a landline? Well, that's this circle. 45 apartments have a landline. 45 out of 80, out of 90, sorry, because there's no condition on this side. And they need to check the decimals perhaps. 40 divided by 82, 45 divided by 90. They are not the same decimal. So these things are not independent. In other words, the condition of having a cell phone has an impact on having a landline, which makes sense to me. Kay, comment on the theory that people with landlines are more likely to have a cell phone than the likelihood of people with cell phones having landlines, based on this. Just kind of, this is a kind of a conclusion type question in context. So I'm going to try to write a little conclusion about each part. So it says the theory people with landlines are more likely to have a cell phone. So of the 45 with landlines, of those 45 that had a landline, that's these, how many had a cell phone? Well, 40. Okay, 40 had a cell. So that means the probability there is 40 out of 45. We're comparing that to the likelihood of people with a cell phone having a landline the other way. So we're just kind of reversing the condition. So of the houses with cell phones, how many had cell phones? 82. How many of the 82 had landlines? 40 had landlines, LL. And so that's 40 out of 82. So they're asking you to more or less compare these, and does one have more of a factor on the other? And I would say yes, okay? Because I mean, this is very high. This is like 90%, and this is only about 50%. Um, so, uh, so I would agree with this. Landlines are more likely to have a cell phone. This is more likely than this. Or in other words, 40 out of 45 is greater than 40 out of 82. So this tends to be true, is what you would say. Oh, wow, look at that. That says tends. Can you even read that? Wow. Tends to be true. Okay. All right. Moving on to the next one. This one is about, oops, I have the wrong document here. All right, we're going to split this video. See ya.